One more minute, please. We are starting 4:29 now, 14:29. Yeah. Greetings from India. My name is Gopi. I'm basically from red zone of India, which is situated in Maharashtra state. Am I audible, Anna? Hello? Anna, I'm audible?
Sir, good afternoon.
Yeah. So basically today, which is a good afternoon to all and good evening to all of the all on this call. Basically, this is a 9th live webinar which we are doing it today on the drives and the automation front. This is a topic which we are going to discuss: water and wastewater. Basically, hope all are in the staying safe and keeping the spirit on the crisis which is we are fighting on this particular challenging period. And on behalf of Nidec CT team, I want to thank to all the warriors, COVID-19 warriors like health workers and the other departments like government, other agencies. Going to the next slide on this. This is basically VSD, it is variable speed drives, investigated on water and wastewater system. This is a topic which we are going to cover today. And this is an outline. Basically, we have 5 sections like introduction of water and wastewater part, and the wastewater treatment and overview and the types and what are the process. And everyone has a role to play, like how we can able to save energy on this water and wastewater, and what we do as a Nidec. It's an overview and stress point, otherwise pain points in this particular industry, and some of the success story and key takeaways and Q&A. Coming to the water eclans, which this is one of the precious resources which is available in the world. Like the ocean is having more than 96%, 96 to 97% of the water is getting hit in ocean, and land is having 3 to 4%, which is we can see here 86% and 14% on the evaporation and 78% on 28% on the precipitation, and 0.001% in the atmosphere. When coming to this, again, we are go with a pie chart, like ocean water having 96 to 97 and fresh water having 3 to 4%, which is we can take it the fresh water split up, like groundwater having 27%, ice caps and glaciers having 72%, and the accessible surface fresh water having 1%. This again we can split up here. Soil moisture having 38% of the accessible fresh water, is having 52%, water with organism 1%, rivers is having 1%, the water vapor is having 8%. Coming to this, water energy nexus and the correlation of sustainable development growth goals, which is set by the global countries, which is basically this is water and energy, and climate is co-linked. Like we can see, this is 17 SDG goals it's set by the world. Yeah, I'm not audible to everyone. I'm not audible. Hello.
It's okay. It's okay.
We can hear you, Gopi.
Swapnil, actually, some of one writing it's not audible. Yeah, that's why I'm asking. Thank you. So coming to the SDG goals, which is we can see that the number six, which is talking about clean water and sanitation, it's get linked to many of other goals. Like 2, we are talking about zero hunger, and 3, we are it's in the goals talks about good health and well-being of humans, and the 7 is talks about on the clean energy. 11 is talks about all the sustainable city or smart city communities. 13 talks about the climate action. So this is 3, which is again like a necessity of right now, that's energy and the earth. It's go linked with this water. Coming to the energy, water energy nexus, like we can see here, 4% of the world's electrical consumption is happening by water and wastewater. And this is from IEA report and the IWA report. Like water and wastewater electrical consumption doubled by 2040. That is experts in the I mean to say they're predicting it right now. And municipal corporation, the EP is mostly, it's consumed more than 30 to 40% on it goes into the water and wastewater. This is if we can able to have a little split on this particular water consumption on water and wastewater, like supplies carry 42%. This is a one which here, maybe it's more than 300 TWH. And distribution is taking around 13%. This is on 2014 figure, which is having a 13%, desalination having 26%, reuse getting it 0.02%, and wastewater having 14%, and the transfer having it 5%. If we see from here to 2014 to 2040, which is a double, especially this desalination happening it more, because mostly we can find a lot of desalination plant coming in each every countries. Going with the water value chain, which we can see the 4 functional value chain here. Like we have a resource function, we are having 1 values, and going the production functions here, we are adding value on this production part, like the raw water get pumped and it's transmitted and the treated, and for the distribution get consumed. That's a final function of final value chain, and again we are retreating back to utilize for the water resources. So little bit on the what are the resources which is available, like groundwater, lakes and drives, rivers, and the oceans, which is again we can from the ocean we can go with the desalination. From there we are getting a distribution and management, and goes into the other usage like industrial usage and the irrigation and the drinking water usage. This is goes to the agriculture and the industries. Again we are taking back to the treatment. So how the typical pictorial it looks like we can see here, there's a river, and the these are the pumping station and desalination plant using for the domestic use, and for the industrial use again we are going for the treating purpose. When we coming to the VSD, why we need a VSD? Basically, this is one of the point which we are going to discuss in detail. Like basically, this energy conservation opportunities which is available in the water and wastewater. That's a one part. So any the budget or in the water and wastewater or the municipal or the government, that energy is having a single line item which is showing it playing a major role in, especially on the water and wastewater. So we can save it nearly about 10%. Just we can approximate for the complete system of water and wastewater. It's a huge saving. I can say if I take it to help one US water and wastewater segment, so $4 billion worth of energy getting it consumed every year. If we are talking about 10% saving, nearly about $400 million we can save it by putting a VSD. Then again, that's yielded a saving of 44.8 metric ton of greenhouse emission happening because of this energy consumption. That is again getting it saved. So what is the overview here? Like water, we can see, as we mentioned, the value chain part, like drinking purpose and the process, which is again industrial purpose, and the wastewater purpose, which is having a usage, how we are using it. Drinking, it's used for the suitable for the consumption, which is the process which we can use it on the desalination, conditioning and reconditioning of the water. Again, we are going for the distribution, where we can use it on the drinking sector, which we can use it on the pumps and the fan, the compressor. It's mainly on the certain areas which we can go in detail in the coming slides. And coming to the process, like industrial, it's used for the heat transfer usage, and the raw is act as a raw material. and having used it for the recover some energy and transport certain items, it's used as here in the process industry. There also it's a pumps and fans and the some other applications. Like coming to the wastewater, this is we have a treatment, and mechanically and biologically and chemically we are doing it. When you coming to the again the application like pumps, centrifuges, and the fans. We are coming to the desalination overview. This is an overview of desalination. Like we have a two different method. One is on the distillation process, another one is on the membrane process. Again, it's get subdivided into multi-stage flash the system, and the multiple effect way we can do it. Another one is vapor compression part. Again, the multiple effect we can do it vertical tube evaporator and the horizontal tube evaporator. When you go into the membrane, which is having RO and the ED, that's a reverse osmosis and the electrodialysis. Wherever I'm showing the red color, it is a heat consuming process. Wherever we are finding it on the blue, which is a power consuming process. Like this is a pictorial diagram, how it looks like the one desalination. Like we have it C, which is having it taking it, pumping it, and goes into the initial solid removal. Again, we are going with the particle settlement, goes on this process, which we have in detail about this description and its process here. Like we have a distillation, what it is we are doing it, heated seawater is evaporated and condensed. That is the process how we are doing it, the distillation. The distillation part, so we can have a little more detail about the process. The same way, multi-stage flash evaporation, which is high flow, and seawater is heated and condensed in the multiple of stages with the different pressure and temperature. This is how it's described on this particular process. When you go to the RO, this is again, seawater is pumped under very high pressure through selective membranes, which is having a different type like natural osmosis and the reverse osmosis and the filtration part. This is a wastewater treatment overview, which is we have a 5 stages of treatment, like influent, which is coming from the houses and the industries, and primary treatment, which is happening in the removal of solids, is to mainly these are the areas where we can use our VSDs, and primary treatment, removal of settable and the floatable solids is a secondary treatment. Primary treatment, this is a second step what we are doing it here. We can use VSD on the primary clarifier and the chemical treatment, and the secondary treatment, which is in biological nutrient removal. These are the areas we can use it: aeration tank, rotating biological contactor, RBC, and clarifier. And the fourth stage of doing a treatment is a disinfection, which is filtering and chlorination, which is a denitrification process, phosphorus removal and filtration system, and sludge treatment and sludge stabilization and dewatering. This is a final stage, which is having a sludge holding tank, a sludge digester, and dewatering, and the effluent. Again, we are getting back to the river. Like here we can see that pictorial view, like this is a pump collection area where it gets screened. That's a bar screen, which is get it screen where we can removal of solids and goes into the grid chambers. And again, we have a pumping to the primary clarifier. This is a preliminary treatment. When coming to this a primary, and we are going with a secondary here, and we are going with this this is a disinfection, and we are talking about here on the sludge treatment. So when a little detail about where we can use our drives, VSDs, this is a preliminary treatment removal of solids. Again, this is subdivided into 3 processes here. Like, we have a lifting station where we can, that power range goes from 15 kilowatt to 900 kilowatt, which is used for the pumping water from the collection basin. So this is an area where we can put a VSD by having it pressure sensor or flow sensor, and getting it vary the speed, which we can save it nearly about 40 to 50% of the energy by putting a VFD on this particular pump. This is a really useful, beneficial to install in the VSD in this particular location. When you come into the bar screen, which is another second step, we have a bar screen and fine screen part, which is happening here. This is having a motor which to take care of this screening portion, which is again we can able to control this particular motor, which is a water level ahead of the screen, which we can able to control it. Here also the saving will happen not much because of the power range is having very less, up to 22 kilowatt. It's having around overall system, we can see 3 to 4% of saving, but this particular area saving is comparatively this area we are finding it less. When coming to the third stage, which is a grit removal stage, which is already we mentioned, this is a rectangular and circular and the cyclonic aerator, which is we can remove it some settling particle, which is again we can use it VFD on this particular portion. The same way power range goes from 0.75 to 22 kilowatt. Second stage of treatment, which is a primary treatment removal, which is having a settable and solid removal, which is we have a clarifier and the sludge pump, withdrawal pump, and we have a chemical dosing pump. This three we can use it VFD already. This is a lift station. We've seen it earlier. These are the area we can use it and save some energy by putting a VSD based on certain pressure sensor, or otherwise we can set some speed based on the season or based on the time which is getting it collected the water, because most of the time water getting it morning we are getting it collected, or there is evening, daytime that's it less. And third stage, which is secondary treatment, which is the biological decomposition and biological nutrient removal. Here we can find it here again. This is aerator. This is the one which is we have combined flow chlor function, which is another one. We have a sewage that is activated sludge and waste activated sludge pump ROS and the WAS area, which we can use the VFD. This again, it saves energy. It's a smooth operation. We can do it and control the process by putting a VFD on this particular treatment part. Coming to the another one is on the disinfection filtering, which I'm going in detail about the water and wastewater treatment, so that to have it a context of where we can use the VFDs. This is a stage, which is we have sand filter and the chlorination tank, where we can put a VSD here. Like this is a lifting station, we can put it already VFD. This is a filtration system, which is having a two type sand filter and the open sand filter, where we can put a VSD for that. What are the advantage we can get it by here. And the second is on the chlorination tank and the pump. This is the one another area we can put the VSDs. It's a final one, which is a sludge treatment, stabilization, and the dewatering, where we can use it dry. Like here again, it's a aerator. It's a sludge holding tank. It's where we can able to have an aeration pot. We put a VFDs here, and this is a digester where we do that digesting portion, which is having a two different pot, like anaerobic and do it. This particular save some energy on this particular location. When coming to the dewatering, that is a tedious and most consuming process. Again, we have a two stages. One centrifuge. This is a particular operation. It's used VFDs. Another one is on the belt press dewatering here. This is two stages of VFD. We can use it. Two stages of this particular function carrying the VFD saves energy by operating on the requirement speed. And this is a belt press. So now coming to I think it's once after going through the value chain and the usage of VSDs, mainly it goes into the pumps, fans, centrifuges, and the compressor. These are the areas it's getting it used. So we are taking to only the pumps as a case now, like how the energy balance getting it balanced in the typical pumping station. Like we are giving 100% electricity. Out of this, 5 to 10% loss goes into the motor, because the motor efficiency always it's less than we are finding it more than around 96 and 97, 98 goes on like that, IE3, IE4. So that's energy loss. It starts from 86, 94. That's energy loss goes around 5 to 10%. If we change that high efficient motor itself saves more than around 6 to 8% of the energy saving. Like 2% losses on the couplings, and pumps are having 15 to 20% losses, which is highest energy loss. And the valves is having 8 to 10% loss, and the pipes are having 8 to 10%, and the work done on the water is having this summation. Coming to the as a pump, when we design it, like we all the general word pump, well, things like this, but we need to optimize it right. That works better for our efficiency, better efficiency to work it. Now coming to the pump life cycle cost, which we can see 5%, which is visible, and the 95% which is invisible. So 80% of the energy, 80% of the life cycle cost goes to the energy as well as maintenance. So initial cost is less than around 20%, and other costs having around 10 to 12%. So this is a one which we are going to take care by putting a VSD, like which we see that there's approximate 20% of the world's energy is consumed by pump motor. Then initial capital and whole life maintenance cost, it's around 5%, which is this is a one, and the energy cost around 95% goes on like this. When we can able to control the motor or the pump with the various control method. That's a impeller trimming, we can do that, and throttling valve we can control the motor based on the demand, and the bypass valve and the variable speed. So VSD is investment or it is expenses on the water and wastewater. The question which we can ask, what is VFD here, and why is VSD, and where is VSDs we can use it? That's three questions we can ask now. Like already previous webinar, as we said, the first webinar we started with VFD and the usage and energy saving. So this is what is VSD. Basically, it's an electronic unit that varies fixed main voltage and frequency to control the speed of a standard AC electric motor. This is we can able to have a fixed voltage and fixed input, which we can able to vary according to the demand of the system. By electronically we can able to throttle the motor. That is what is all about VSD. When I coming to the why is VSD used, the first one is on the inrush energy saving, which we can see any motor we can start it through this particular way of doing it. Like direct online motor starter, we can use it. This is a block diagram, and star delta starter, and the soft starter, and the frequency inverter. When we talk about voltage curve, this we can see here how it's clearly how its voltage curve talks about. This is big champ which goes 100%, and again it's smooth. When I go here, we'll have a frequency converter which is smooth incremental. When I same way go with the current curve, which is again 6 times we need to pump on the full load current or rated current of the motor, well, starting purpose for a certain second. After that it goes down to the rated current. When you go to the star delta, again it is 2 times of the full load current, and so again it goes down and again pick up and coming down at this rated current. Then when you coming to the soft starter, it is around 3 times of the rated current and again coming down. And I go with the frequency inverter, which is we can able to our VSDs, we can able to design our starting current requirement based on the ramp up time and the ramp down time. So that's a smooth takeoff and smooth landing which happen through a frequency inverter. The torque curve also it talks about little more about what does the torque characteristics looks like. So I'm taking it interest current saving. It's small way of doing it. So it's basically a capex saving by putting a VSD in the plant. So I can imagine one of the plant having it 0.75 kilowatt to 1000 kilowatt motors, complete having a total energy motor capacity is around 5 megawatt. So rated current for the 5 megawatt may be around 10 kVA. When all the motor getting started by DOL, so we need to have a transformer, otherwise power demand for that particular factory is around 60 kVA. When you go with the star delta, which is having around 30 kVA based on this particular demand curve or otherwise current curve requirement. When it goes with the soft starter is around 30 kVA. When it go the VSD is having 20 kVA. So we can able to save that particular capex investment, either it is a transformer or otherwise power demanded by the institute, maybe the government agencies, that we can able to save it on the interest current saving. When it coming to the energy saving, it's a operating expenses saving, which is OPEX saving, especially on the pumping part. When it coming to the pump, that follows affinity law, pumps, fans, and the compressors follows affinity laws. The flow directly proportional to the speed of the motor, and the pressure directly square of speed directly proportional to the square of the speed. When I go for the power, it is a cube of the speed. So what it in terms to as basically 10% decrease or increase in the speed of the motor, which is again increase or decrease 10% on the air delivery or flow of the pump. So when I coming to the pressure, which is again I am increasing or decreasing 10%, which I am doing it, we are doing it 19% variation on the 10% variation on the speed. Here again 10% variation on the speed, which is clearly talks about 27% on the energy saving we can put at VSD on the pumps. This is a second advantage on the using a VSD in the pump or the fan or the compressor on the mixture or centrifuges. Like third point on the automation, this is one another stress points which is every industry is going through now. It's automation and the staffs are very less. It's automation is a one another point which is going to one other driving factor for the every industry for the technological innovation. So this is getting it used. Our VSDs or IO4 industry 4.0 capable of doing it. That we can able to do it on the automation using this but Nidec control technique VSDs. Coming to the where we can use VSDs, as we mentioned the all the slides like pumps, fans, compressors, and mixers and centrifuges. Wherever we'll find rotating equipment and the demand is always varies, that VSD is a right option for using it. Little in detail about energy saving, putting a VSD here. Like when we see here, this is a system curve of the pump. This is a fan pump curve. When the operating point of the pump, which is we are talking about 100% energy consumed on the 100% speed, which we can able to reduce it around 20% on the speed reduction, which is we are from 100 to 80, we are moving down on the speed, which we can save it around 50% of the energy reduction by using a VSD. When you go with 50% speed reduction on the pump, 80% reduction on the saving on the pump. So always that that peak load condition varies. What it means basically the seasonal variation and the day variation, it's always the pump water it's having it. Water flow always varies. So that way we can able to save energy by putting a VSD. And second part is on the every equipment getting it designed little oversized because to take care of the critical situation. So that itself save nearly about 20 to 30% of the energy. So other than energy save, what other benefits we can get it in the using a VSD? Like we can use it for the reduced water loss. How we can able to use it? This is one is we can use it for smooth starting and stopping with the VSD. It's having a it's reduced mechanical stress, and we have a less damage to piping as well as walls, and lower possible system operating pressure, also reduce water loss. This is the one way we can able to save water losses in the distribution system. This is all about water and wastewater. We are going in a little bit detail about what we are doing as a Nidec and CT as an overview. The history starts 1973. So we are in the 7th generation of drive manufacturing right now. We have more than 1,600 employees all across the globe, and we're having 5 million product which is in operation. Every year we are making more than 700 numbers. We are making it. We have more than 1,000 OEM customer, and we are active about 70 countries. 2017, which is acquired, we went with Nidec. So that is Nidec is a pioneer in the motor, which is a leader in this particular field. So we are having it with them. So we are growing now. Like the range which we are talking about drives, which is having from 0.25 kilowatt to 0.8 megawatt that goes. It's this particular drive suits for both constant and variable torque loads. Nothing but we can use it for the manufacturing as well as process industry. And this is having a inbuilt PLC, which is having a protection function, which is STO and other functionality which is in the drives. And we have optimum ingress protection IP rating, and we have high efficiency drives up to 98%. So all we talk about lowest cost of ownership. And when you're coming to the drives and soft starter, especially in the context of water and wastewater, It's running more than 1,000 numbers all across the globe. And like these are the areas like power generation. Maybe I'll have one slide on the success stories. So when we talk about water supplies and treatment and wastewater treatment, pumping station and irrigation station, we have 45 years track record globally and in Asia Pacific. Coming to the water solution, this is a Nidec Way what we do on the product, which is available right now for pumping application. Especially the Commander C having a 5 years warranty, free warranty, which is available. And we have a pump drive, which is a F600 and F300, flow drive of F300, which is having 5-year extended warranty. We can extend it. Standard warranty above that we can extend. Certain functions specifically used for the pumping application, like handoff mode, cascade system, which we are going to explain again on one another slide on this. Sleep mode, dry run function. This all the function needed by the water and wastewater segment or the pumping station. Like T-racking is again, I have one another slide for this, and multifluxing and under overpressure, cycling and no flow, pipe fill, switch control and PID controllers. I think this particular slide getting it shared with the team, so they, maybe you can go through that. If you have any doubt, I can answer it in the QA section. So this is on the particular Nidec Way, what we are operating in this particular water and wastewater segment. So what we are talking about is total cost of ownership. It's getting it simplified by using Nidec control technique drives on this particular segment. Again, this is one another point on this water and wastewater, which we are talking about 3C2 class environments, which we are having one another slide on this. Coming to that one point which already we mentioned, that is duty assist, which we have a drives. We can use it for the fixed duty motor with the one single drive up to 4 motors. This particular motor all running with a flexible starter. This particular drive, we can start it at the starting point as a starter. After that goes into the 100% speed. This particular pump working as a variable speed pump. So this is one way we can do that. Another way we can do for flexible duty selection. This particular VSDs, getting it used any of the motor, we can be able to vary based on our time requirement. That's a duty rotation, we can do it. So here it is a fixed speed, one variable speed. Here also the same, but we can able to rotate the VSD with the pumps based on our requirement. So the reason we came up with the one another product, drive freestanding, it's a pre-engineered VFD for standalone requirement, having from 55 kilowatt to 500 kilowatt. This specifically, we came up with this particular product. Wherever the emergency breakdowns and the need replacement drives quickly, that particular drive is getting it shipped any region of any country. That we have a setup in all the drive center on this. We can go up to IP54 and having inbuilt EMC filter, another other energy monitoring empty section for the customer equipment. This is a one another product which we can able to offer in this particular sector, water and wastewater. Some of the stress points and solution from the Nidec control technique. That is, one is on the energy saving. Yes, that's a one we are talking about, especially consuming 4%, which is this our VSD getting it used for the energy saving and goes for the energy neutral and as a solution. And the harmonics, it's a one another challenge. You find it in this particular industry. So what are the problems which is mentioned here? We have excessive heating of induction motor, higher noise from the transformers, like poor power factor and high current for given power. And this is some of the practical problems which we can find it on the harmonics. Why? Because remotely locate this particular industry, this particular operation. So the power quality also one another issues. What we have it in our portfolio, like we can use it the AC or DC chokes, and the 12 pulse arrangement is a 12 pulse arrangement. We have active front end solution, which is having it the one another way we can mitigate this harmonics. And this is another way: active harmonic filter and passive harmonic filter. Both we can able to put it in front of the VSDs to save the harmonics and the power quality part. Coming to the product reliability, especially this particular installations happen in the remote as well as the high temperature zone. So having exposure to H2S, we have a conformal coating designed for 3C2 class environment. So this one another advantage using a particular industry. Coming to the protecting the mechanical equipment from damage or blockages, this is a deragging. We have one another slide on this. I will explain how it is. Maybe one of our colleagues from Sydney may help me out, Mr. Adam. I may ask him to join on this particular slide. This is one another point which we can having it in our inbuilt function in our VSD that's getting it used. When product availability and installation time, any audio issues? Hello? I'm audible?
You're fine, Copy.
Yes,
keep going.
Yes, Copy, we can hear you.
You can hear me, Adam?
Oh, yes, we can
Yeah,
hear you clear.
loud and
Because,
clear.
you know, Stoppy is writing its check audio. Yeah, okay. Fine. So coming to the and the replacement drives need quickly. We have a drive freestanding, so that's get shipped little as 1 week. So it's onboard pump and fan functionality as a standard, so it will help us to install the system short duration. So Adam, I think you need to help me out here. I may take your help. Next slide, if you're okay, Adam.
Yeah, sure, that's okay, Copy. Can you hear me okay?
Please.
Yeah. So when we were discussing this presentation, we talked about some of the challenges that our customers have, and we've just talked about Harmonics and that we have a number of different flexible solutions that we can prescribe to Harmonics issues. The one thing that we see, particularly from consultants right now, is that we see a kind of a one-size-fits-all solution that finds its way into specifications. And what I mean by that is that there's a number of catalog harmonic solutions out there on the market from various vendors that claim to offer low harmonic outcomes straight out of the box. Now, when we look at different installations, the one thing that we can see is that there's often no consideration really given to the process or the specific system that's going into, say, a raw water pumping station or a wastewater treatment plant. There's just a specification for low harmonic drives, for example. So what we encourage our customers to do, and also the consultants that we're dealing with, is to look at each application on its own merits. We have the tools to be able to help with this. And the outcome that we really want from this is to have an optimized harmonic solution specific for each application in the water industry that makes sense and provides the best value. So Harmonics is not a one-size-fits-all solution. We think this is the wrong approach. We think the right approach is really to look at the installation, to measure and prescribe the right solution for each specific project. So that's all I have to say on that one, Copy.
Yeah. Thanks, Adam. The next slide, please. There's over 2 slides.
You did this one too? Yep. Okay. So
yeah.
One of the other issues that we hear from the water authorities around the region in Asia, also in Australia, and I think globally really, is this problem with the usage of wet wipes or so-called flushable wipes. It's a big problem because the sewage systems, the wastewater systems are not really designed to deal with this. There's various pumps available that can grind the wipes. There's also some inline macerators that are available to sit in the pipes that can actually grind up this stuff, but that creates some other problems in blocking screens with smaller particles than the rags themselves. So it's a very complex solution, but often these lift stations, you can see on the graphic there, where we have the sewage gravity feeding into a wet well. That's an emergency storage vessel off to the side for wet weather events. But the sewage ends up in the wet well, and then it gets it sits there, clogs up the pump, and then we have to send a maintenance crew out to go and pull the pump out and block it. So what we've come up with is in our drive we can actually call on the deragging function, which detects this in the submersible pump and puts the impeller through a series of movements so that it can actually unblock itself. That obviously saves time and money, and it also saves the potential of the sewage system backing up for prolonged periods and creating odor and all sorts of issues. So that's quite a valuable feature in our drives and worth looking at.
Yeah.
Thanks, Scott.
Thanks, Adam. Thanks, Adam.
No worries.
Yeah. So we are coming with the final slides on the success stories, which we can able to. We have more than 1,000 numbers of drives, which is running in this 1,000 plants, which is running on this particular drive. So this is the one which is happened 10 years old pump where we revamped with control technique drives, which is having SPMD 1423, which happened in Taiwan. This is a motor, and this is a drive which is a inbuilt. You'll find chokes and the filters here. Like this is a water test CT scope. Coming to this one another OEM based out in Chennai. It's very last year we supplied with this. You can find it in the cubicle which is shown here. This EPC contractor also is based out in Chennai and Hyderabad, and end user based out in Tuticorin in south of Tamil Nadu, which is having that's a 1 into 525 megawatt coal based power plant. Where the consultant again based out in Bombay, it's a EPC consultant again Hyderabad. So what it is a desalination plant, what we supplied for 10 MLD desalination plant, which is a F300, it's a flow drive with a series, which is having a passive harmonic filter, which is what we are talking about, harmonic mitigation techniques, which we used in this particular project. When you go with a high pressure booster pump, this is an area where we've used 225 kilowatt faucets and the backwash pump and the other areas what we use in this particular project. And the third one is which we want to show that is in customer is in based out in Bhavnagar, which is in Gujarat. It's western part of India. The consultant, engineering consultant is in Chennai, and the EPC consultant in Mumbai. The project is 1 into 82 megawatt power plant. It's a 40 MLD water plant, which is having a byproduct of salt here, getting it manufactured. This is again the cubicle. We can see that's the longest cubicle, which is manufactured in Chennai factory in India. So having its total supply, we made around 4.5 megawatt load, which is from 11 kilowatt to 101.2 megawatt. It's having certain section having a long cable solution. Why that it's a distance from between the motor and the VSD is long, so we have a long cable solution also we provided in this particular project. And the power drive and which is MD2CS and the unit drive M600 where we supplied here. This is the one which we did last year. Even they get commissioned the month of March before COVID-19. This is it's happened in the Bangladesh Development Board. There's a pump which is used. It's for the water pump application. 400 kilowatt and 13 numbers, and 30 kilowatt of 22 numbers, and 11 kilowatt 2 numbers what we supplied. So just I want to show a little video on this. Maybe it's audio, maybe we you may not get it, but you can see how would this video it shows here. Sorry. Yeah. Yeah. So this is the one what recently we supplied. So final slides before here, it's a key takeaway on this particular presentation is using a VSDs. One is on the cost reduction, especially on the energy saving. It's approximate bare minimum around 35%, which is compared to the throttling valves modulation method, which eliminate of expensive valves and the valves control and the simplified pipe systems and the no need to oversize pump system because it's having it VSD, we can able to regulate the motor by electronic way. And electrical advantage, again, as we said, low inrush energy saving and low torque surges, it's having less mechanical stress and prevent water hammer and the gearbox damage and belt breakage. Reduce surges and the stress associated with across the line trotting and main strip right through, and better system control, like provide accurate flow control without the need of PLC, the simplex and multiplex PLC. Pipe filling algorithm we can do it through VSD, like pump operation sharing by automatic programmable master and slave concept, reduces maintenance costs and increases production yields, which is water hammer and control and the reduced pump vibration. So overall, we can talk about on the here by using a VFD, basically it's energy, it's a efficient and the effective. The three getting it used in this particular VSD using in the water and wastewater. So as we mentioned earlier, this is we are going with the three water is scarce resources which is everyone needed. So like that approach, what we are doing at 3R 1A approach, majorly this automation used for the VSD is used for the automation and digitalization. Like energy and water and climate is a correlated. So we need to use this particular approach so that need a control technique VSD will help us to make it energy neutrality and the energy positive. So this is all about from my end, and my it's Adam also it's given. Thanks Adam on this, and final slide Q&A. If any questions, most welcome. Any questions? Hello. You can put it in the chat box. Any question is there? Yeah, Krishna. Maybe I think Anna, you can unmute Krishna if he is there. He raises his hand. There I can go. Just hold on, Krishna. I'm unmuting you. How many VFD we have supplied in India for water and wastewater treatment plant? That's a question came from. Yeah, we have a list of reference list we can able to share with you on this particular question. I think Mr. A.K. Paradwaj. Yeah, Paradwaj. We have it many installation in India. We can able to send it to you. So Andrew Zupo is asking about, sorry, I came in late. Do we have multi-pump application, please? What it, can you able to elaborate this question, Andrew? I'm not getting it.
Gopi, it's Adam. I think, yeah, I think the, I think he was asking on the multiplexing function and also the duty assist function.
Adam, I'm not getting it. So what he's asking?
If we have a multi-pump function, so I think we covered that in the the multiplexing.
Yeah.
section.
Multi duty assist. Yes, it's possible, Andrew. It's here available in our drive. We can go up to maximum 4 and 3. If it is that's duty assist or cascade system, we can do it. Yeah, one another Ronak shot. If we have 4 working pumps of similar type, as each pump motor unit will have individual VFD, or we can have one VFD serving for all 4 pumps which are in parallel. Okay. Yeah, Mr. Shaw, I think that's basically demand of the system. How it is the demand requirement. So if it is, it's a demand is one is a variable, another 4 we can work it as a constant speed, certain application we can put it all the motor, all the pump in the variable speed. So whenever you are putting variable speed drives in each and every motor, that save a lot of energy than putting it only one, but depends upon the application requirement. Like Bharadwaj again, he's asking about MVD also for pumping system. What can you able to elaborate? What is MVD? You are talking about medium voltage drive, Bharadwaj? Here. Yeah, medium voltage drive, we have control technique as CT. We are not having it. Our sister concern, that is Nidec Ansaldo from Italy, we have it medium voltage drive. That we can go up to 250 megawatt. We can supply drive as well as motor. Yes, it's available. Not in the CT brand, but it is in the Nidec Ansaldo brand. Yeah. What does one another questions again? Yeah, I think Mr. Das, we will receive a copy of this presentation. Yes, you will get it. And can this inbuilt PLC able to handle PID? So this is, I think I need to get it some more detail on this. Mohit, please send me that your query little project base. I can reply you back one-to-one. Can the VSD create damaging current through bearing? Can the VSD create damaging current through bearing? So what did you want to say here? This is you mean to say the VSD will create any damage on the motor bearings? That's a question. Yeah. See, basically, that's pumping application. We may not allow to go certain speed less, maybe around 30% of the 30 heads, which we can go. Below that, always it's a risky for the motor. Why? Because it's self-cooled motor. So 30 to 35% is allowable speed reduction we can do. That itself save a lot of energy. As I said, 50% reduction speed itself, save nearly about 80% of the energy. That's itself possible. So can VFD and soft starter can both work together in pumping station, or VFD in alternative, or soft starter with additional feature? Okay. So this question is both in any pump, as I said, the starting method we can do it any bypass arrangement, like anything goes wrong with the VSD, we can run that motor whether it's a soft starter or otherwise dual or start delta bypass. So that's we have a standby arrangement for any motor starting purpose. Like the soft starter functionality, basically, Ronak, this is for the only starting purpose where we can able to save energy saving, but may not use for the continuous saving by putting a soft starter. So that's VFD is basically for the continuous energy saving. So it's possible you can put it both, but you need to have a different arrangement for that. Satya, VSD generate campus. Okay, I think he's giving answer to the team, it seems. Yeah. Satya, maybe you can unmute yourself. You can explain any question here. Satya, if you want me to unmute, I'll unmute. Thanks for all the questions. I'm unmuted, Satya. Maybe you can answer that. I think some question you want to give an answer, it seems.
Yes, based on the bearing question, whether the VSD, it's not necessarily our VSDs. Every other VSD has this tendency to create a EDM current, a shaft current. So what happens if we do not have a VFD or VSD duty motor is that the bearings will not be insulated, so the shaft current will be shorted or will be leaking to earth through the bearing. So this would create damaging effects on the bearing. So a VSD duty motor would be effective to be used with a VFD. If you do not have it, then we will need to have mitigation methods to make sure the current on the shaft is shorted or is leaked to the earth point to ensure our bearing is not doing the connecting point, or it is not being used to be discharging those currents. So that's how we would work with non-VFD duty motors with a VFD. So it's not necessarily because of our drive. It's every other VFD has the similar effect. So that's answering the question on.
Please talk about can the VSD DEH. I think Dave was asking about the question, Satya. Good.
So, yeah. For
Rick, I think
then,
its answer is okay. Okay. So Shekhar Chowdhury, he's talking about
another question.
Yeah, please.
There's another question on inbuilt PLC being able to handle the PID. So we do have inbuilt PLC, but we also have inbuilt PID controllers. So it depends on the drive. For our Commander series, we have one PID controller. We have for F300, we have two inbuilt PID controllers which we can use. And also we can use the inbuilt PLC to have our own PID control. So we have a standard setup or standard configuration to be used for PID, and we also have an inbuilt PLC where you can work with your own PLC, so PID constants and controls.
Yeah, Satya. That question was, can this inbuilt PLC able to handle PID? That's question from Mohit.
Yeah.
So it's possible.
It is possible.
Okay. So I think Mohit, the answer is given for your questions. Okay, and Mr. Shekhar is talking about, can we get protection for the dry run in VFD? Yes, it's available with our VSDs, Shekhar. I think one of the slides which is being shown it here, I think I can go that particular slide. Directional very well, it falls below the set point, and output frequency is within a specified bandwidth. This is available with our drive. Okay, then it comes to, can you please elaborate on how master-slave application of VFD works in parallel pumping system? Okay. We need to go with both the answer of Andrew and as well as Ronak. Where is the slide here? No. Yeah, maybe I will ask Satish. Satish, if you're there, you can able to explain a little bit. Maybe you can give a little expert opinion on this, Satish. Yeah.
Thank you, Gopi. This multiple pump, mostly pumps as well as fans often works on a parallel to reduce the system as well as overload function. This control techniques has a duty assist function where we have a specific software has been developed with work as a duty as well as assist logic. You can see a typical example where we have a tank of reservoir where kind of inlet some filled with this thing, and there will be a level transducer that also will be connected to your drive, and this will monitor the drive, and based on the pressure level demand, the drive will switch over the assist start 1, and if assist start 1 started and it's run complete full speed, then its further move demand is started. Then drive will take a call to start the next start. Like this, it will keep continuing up to 4 starters. This we called as a fixed duty motor start. And this parallelly, if the demand goes level comes down, then automatically this one by one all motors all been switched off. All the things intelligence has within the drive, no need of external controller. We can do a communication with PLC, where if you want to do the set point changes and all, we can do by HMIs. This is one method where we can do a fixed duty motor up to 4 motors. So same motor with this configuration, the drive will be connected always with this motor. Remaining all 4 motors are connected by either soft starter will be a start. Meaning these all motors always will start DOL, means you have a huge starting current, you have a mechanical guarantee, and it will not be equally distributed all 5 motors. So other solution where the same software, what we can do is we can do a same drive with the help of output contactor changeover. This we call as a flexible duty. With this solution, in some time we can work one drive with this first pump. In the second time where we can work with one drive, the same drive with second pump. In this way, we can able to do our duty rotation. At the same time, all the mechanicals will be equally wear and tear will be equally happened actually. So this is the idea of this flexible duty as well as fixed duty solution with us. Hello? Hello?
Oh, sorry. I think I'm unmute. I'm unmuting. Satish, thank you so much, Satish. So Ronak, basically the two case question which is getting it answered on this duty assist. Basically, one drive ideally we can go with one motor with one drive. That's ideal concept. Why? Because having a lot of energy. Like if we see here, I'll put the maybe time is little running out. 2 more minutes, I'll close it. So here, if you see here, this is one of the cooling tower we can see. This is a one drive, one motor. We're having a one drive. Just if you can imagine. So what will happen if you are running all the fan at the same speed? That imbalance is not happening on the mechanical part. So the mechanical stress get reduced if we are running with every motor in the same speed. Suppose we have a common drive, getting it used for all the motors. Here we are running it 100%. Again, it goes on 100. This one is going with the variables. This is always less loaded. This is getting it loaded on high. So that's mechanical imbalance will happen. So the mechanical stress on the pump or the system will be happen. So ideal requirement will be one drive, one motor. That's ideal solution. Suppose the cost is a major factor, otherwise the system is not demanded that particular requirement. People go with this another concept of going with only one drive for the multiple pumps. This is a one that particular drive, it's getting it used for the first one to start, goes on like this. The final pump it is used as a variable speed. That other way here, the same concept, only thing we are varying that timing for that motor, which is getting it engaged on the VSD. Ronak, I think we cleared a little bit on your queries. Maybe we can have a discussion one-to-one along with our team. Maybe I think Macno also is there, Mr. Prakash, but he can able to visit you at your place to explain. No issues, Ronak. Thank you.
Perfect. Yes, surely. Why not?
Yeah, sure, sir. Thank you, sir. Okay. So thank you so much for your participation. Stay safe and stay well. And we are winding up. Thank you. Bye.